Okay, so let's get started. This is about a solution can exist in any state. Yes, that is correct. The solution can exist in any state. We can make solutions out of solids, liquids, and gases. It does not really matter which state it
Mm,
is.
yeah.
So you can comment. Okay, so there are some specific skills that are covered in this portion. Good, great. Okay, let me see what that is. All right. So the learning objective is that to investigate that the presence of other atoms in a metal breaks the lattice and gives them modified properties. Yeah, a very good way to do it. All right, let's see what we have next. Okay, almost all learners can demonstrate the arrangement of particles in a
So you
solid
can
metal.
skip this.
Okay, let me see. Just a minute. Mhm. Okay, so we're going to go with the same learning objective. Metals are good conductors of heat. Relate this property to the structural arrangement. Uh, we just said so that it actually is due to mainly due to the vibration of the cations or the positive ions, and it's partially due to the freely movable or delocalized electrons.
Yep. Okay.
Reference to structure explain how and where metals are good conductors of electricity. Delocalized electrons can move throughout the structure and can carry the charge. What's an alloy? Alloy is actually a mixture of metals, sometimes even a non-metal with metals. So
Mm,
when we put metals, when we mix one another, and the way of mixing them is really easy. We convert them into liquids by melting them, we mix them thoroughly, and we solidify them again. Now, A is an alloy, B is a pure metal. How do you know? We know because the alloys
because
have, yeah, go on.
because as you said that alloys are mixed with non-metals as well. Over here, we can see some dark balls. I think they're non-metals, so they're mixed.
No, metals are usually mixed with metals, but sometimes with a non-metal. So most of the time, we'll
Mm,
be mixing one metal with another. Since two
all right.
different metals would have two different atomic sizes, that's why we can see two different size balls over here. The
Yep.
dark
Okay.
ones, the light ones, and we can even have an idea that one of them are bigger in size than the other. So it's quite clear from the diagram that the dark ones are slightly bigger in size than the lighter ones.
So
B
which
is
one
a,
is correct?
that is all of it is correct. There is nothing correct or incorrect in here. We are
No, no,
using the
no.
images to explain the differences between pure metal in B and alloy in A.
Oh, okay.
There is nothing incorrect over here. Actually, these are two different structures, and we are trying to describe the difference. So that was
All
the
right.
whole description. That was the whole description, not the whole, actually, the whole description that we went for. That A is an alloy because there are two differently sized or differently colored balls in there, representing maybe two different metals. And B is a pure metal because there is only one kind of uh, atomic structure we have, or one colored balls, or one same size balls. So, yeah, that gives us the idea B is a pure metal and A is an alloy. All right.
Yeah.
Okay. So explore on why alloys are harder than pure metals. Now, pure metals we can apply force and the layers are going to slide over one another. Now, if we take the example of this alloy in front of us, and let me just annotate this to make sure that you understand it. Now, let me see. If we're going to apply force over here, they would probably easily move. If we're going to apply force over here, now the problem is if these particles try to move, these bigger sized particles are going to provide resistance. This resistance is towards the resistance in change in shape, and that's what we call hardness. We're trying to reshape it, it's trying to resist towards reshaping. This is what hardness is. Hardness means
Mm,
difficulty in reshaping. And since there are differently sized particles and they would require different amounts of force to push them or slide over one another, so of course they are going to pose hardness. They are going to pose a difficulty in getting reshaped. And that's what hardness is,
Yep.
right?
Okay.
So they
Yes.
are actually trying to explain hardness at an atomic or molecular level by giving simple diagrams to children. And that's a very good way of teaching it. So I really appreciate the whole effort. Okay.
Mm,
So
yes.
moving on, let's see what we have next. So in an alloy, different metals have slightly different size atoms. This breaks up the regular arrangement and makes it more difficult for the layers to slide. So an alloy is harder than the pure metal. We can explore it, and the arrangement of atoms, different sizes, ensures the same thing. Now, after this objective, the students can understand metals have metalline and delocalized electrons, how electrical conductivity, how the structural preference actually can help us explain electrical conductivity. Metal conducts electricity, but not glass, because it may not have any moving particles such as delocalized electrons. We can also understand that the size of particles are different in alloys, and that's why alloys are usually harder than pure metals. And alloys are usually harder than pure metals. I hope this diagram is simply explained over
Yeah.
here in terms of hardness. But when we studied, I told you if we gain one more property, we might have to compromise on the other. So in alloy, if we have a better hardness, we might have to compromise on malleability, on ductility. Now, since it's harder, it's difficult to reshape it. It's going to take more effort, it's going to take more force. So yeah, we have compromised malleability and ductility, but we have introduced a new property or a new level of hardness in the whole system by converting a pure metal into an alloy by mixing another metal into it. All right. So we studied it actually in more detail as far as I
Uh,
remember, but I don't know
okay.
whether you remember those details or not. Okay.
Yes. Sir, you can skip this.
This is this for your class? Because I can see your name right next to 5 and
Sir, don't see. Skip, skip.
why skip? Oh, it's
It's
Cat
like
34 and PTS explains this.
actually, I think it's according to your level. They make you head to the students who are with your level. I guess that's what.
And that's not exactly what this is,
I don't
but
know, sir.
okay, you were naming something the last time as your best friend, but I can't find that name over here.
Sir, she was in my previous school. Now she's not there with me
Oh,
anymore.
all right, all right.
No.
I thought, uh, yeah, I can't see no written over here. Okay, let's move on. So, peer review, delocalized electrons. Electrons are supposed to move, they carry the charge, they conduct electricity, different size of particles, alloys, specific properties, metals are malleable. We evaluate the whole thing. There we go, we are done. Any questions?